Hello, and welcome to the Smith Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. And I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. All right, now I would like to introduce our presenters and go over today's agenda. So with us today, we have Alan McNeil. Alan is a product line manager of FRIT and waveguides. Also with us today is Joe Emsley. Joe is a product line manager of FRIT products. So for today's agenda and today's goals, we're going to be looking at a few things. What do we mean by MFAs? We look at examples from the past, present, and future. We're also going to understand the trade-offs in deciding whether to opt for an integrated versus a discrete assembly. We're going to discover the benefits of MFAs in the space and defense industry. And you can decide for yourself if these benefits will work for your applications. So with that, I'd like to pass things along to Joe to get this webinar started. So Joe, go right ahead.
Well, thank you, Katie. Appreciate the introduction. Alan, good afternoon. And looking at slide 1 and focusing on waveguide coaxial strip line and microstrip product as it relates to passive multifunction assemblies. What do we mean by multifunction assemblies?
Well, Joe, as a manufacturer, we design and produce a variety of products for a very diverse range of applications. Now, some of these products are relatively simple components, but when these are supplied as a small system comprising more than one component, we call that a multifunction assembly or MFA. And in the slide on your screen, what I've tried to do is look at the main functions that we can integrate. So that's isolators, circulators, filters, etc. And the different topologies, waveguide, coax, strip line, and microstrip, and put our experience, and by experience I mean products that we've supplied into at least one industry in terms of frequency. And in the lower box, I put the different markets where we play, space, defense, avionics, etc., and put in waveguide, coax, strip line, microstrip, and these are actually not only components, but the multifunction assemblies that we've supplied into that market. So I guess the purpose of this slide is to explain the limitation of our capability, what we mean by passive components, and our experience in making MFA.
Well, thank you, Alan.
So, I was just going to say one more thing, Joe. In many cases, the products that we supply are physically adjacent to each other within the system. For example, an isolator could be attached to a filter, which is in turn attached to a coupler, etc., forming a chain of function. And in this following example, which Joe's about to put on the screen, we can actually show an example of an MFA, or it could be supplied as separate devices.
Okay, thank you very much, Alan. Moving to that next slide, versus MFA versus individual components. Would you like to expound upon that?
Yeah. Well, this is a real life example of a product that we've supplied for many years, and you can see there that you could consider this as 5 separate products. And if you were an RF design engineer, you'd have to look at each of these components separately. You'd have to write separate specifications for them. You'd have to build in design margins for each. And then you'd have to work closely with the mechanical engineer responsible for putting the whole thing together. And then reiterating with up to 5 suppliers all these products are going to go together. As an MFA and the RF mechanical requirements can be simplified, then you could put this to your supplier, and the supplier can actually guarantee the interoperability of the components, and it's a single conversation, it's a single specification. So in this slide, you have a transition, you have the half-height waveguide circulators, etc. You could actually bolt these together or integrate them into one single three-port device. And as a three-port device, it's simpler to specify, and you're really putting the onus onto your supplier to come up with an ideal solution. So if you can advance the slide, yeah.
And again, focusing on the components combined into one, would you like to comment on the picture of the two products?
Sure. So we've got two products here. The Q-band products, so working around about 40 gigahertz. On the left-hand side, you've got an inline transition, and then you've got an isolator. And you can do lots of various things with these devices. In this case, our customer, they were looking for a coaxial isolator. And a coaxial isolator with a very high specification is a very challenging product. So what we offered them was two transitions and an isolator, and we said, well, you can go and make your own coaxial isolator. The problem was that they were short of time, and they were very concerned about the specification. The market, especially, is quite an art form, and at 40 gigahertz, the difference between success and failure can often be a fraction of a micron in terms of alignment. So, Joe, if you can go to the next slide.
Of course.
Yeah. You can see the component that we eventually supplied. Now, it's really, really simple, and it's the simplest components you can do. In fact, some people would not even consider it a multifunction assembly. But I'm using this example as illustration of what an MFA can be. And most are much more complicated than this. But the main advantages to our customer in this case was it just was guaranteed performance. They were subcontracting the risk to us.
Understand, Alan. Looking at that example, it's not immediately obvious why a designer would specify the assembly over simply buying the parts and doing it themselves. Would you like to expound upon that one?
Sure. It's a key question, Joe. There's nothing we do that couldn't, we're producing it. We ask every time we offer. So, an example, these parts and then it was just the cost. It was in this case $4. And then being together, they saved some money. It only had to build just one part. So again, in this case, it was fractions of the dB advantage, us doing it, bit of cost saving, and I guess maybe they were too busy to do it themselves, and that's also a consideration.
Okay. Alan, we had some technical difficulties there. I believe the salient point is that in the specific example above, actually the chasing of the fractions of the dB was the overriding item, and I guess and I guess if the customer had, in this case, the customer only had to write one specification, procure and manage one assembly, and save themselves some integration time. Are you in agreement with that?
Absolutely. It's true. It's a very simple example. My personal opinion is that when you go an MFA in preference to a component solution, you must be looking for more than just a bit or a small bit gained in the MFA approach. Because to justify an you need to be seeing, stakeholders must be seeing some kind of advantage. And I think the next slide kind of hopefully illustrates this.
Yes, so looking at the next slide, can you go into detail of regarding the mechanical structure, the robustness, and the thermal management properties of that device?
Yeah, so you can see from the schematic on the left-hand side, basically we've got eight inputs being combined together in a signal combination, and then going through a high-power isolator. And this system was designed for a satellite on the move application. It was going into a vehicle. The space was really, really tight in this vehicle. The thermal management properties of anything that go inside the vehicle are clearly very important because it has to be kept cool. And so there's no size, the weights are a premium, the thermal properties are important. So a decision was taken to go down the MFA approach because not only were they getting better electrical performance, so the insertion losses were lower, but they were also able to use this MFA as part of the mechanical structure of the transmitter. And by that, what I mean is, and it's difficult to see from this image, on the reverse side of the product, our customer had a bunch of electronics bolted to this. Our device was used as a heat sink, and you can only really have an efficient heat sink if it's a continuous piece of metal. So we've got 8 times 20 watts going into the, and you've got approximately 160 watts coming out of the isolator. So here we ticked the boxes of improved insertion loss, lower mass, a more robust structure, and it added this intangible benefit of being so ticked every boxes. And I guess another way of looking at it is, had you made this component from just a bunch of different parts, the tolerancing on the components would be pretty severe. And it would probably have just cost up.
Understand. And to summarize that, besides the footprint and obviously the less insertion loss, the thermal characteristics of this package as it related to the amplifiers was critical. Would you agree?
I think looking back, it wasn't immediately clear at the outset that the thermal problem was the problem to solve. But at the end of the program, looking back, certainly the number one advantage of this was the thermal management properties of this device.
Okay. Thank you. Well, so let's move on to the next slide and talk about the multitude of components within it.
Yeah, I guess there's quite a lot going on in this. We've got hybrids, we've got 8 structures, we've got an ISO, lots of those. There's a little coupler that you can't see in the image, so I left that out the sum. But there's a lot going on, and it's quite a broadband device. Anybody who's worked with Move is going to know that this is a broadband device. And I don't think we would have actually met the specification had we done individual components. Because every time you've got a flat coupling at X-band, they're losing about 0.05 of a dB, I think, easily.
I understand. We're having some technical difficulties here. Just to repeat, there is 23 components in that multifunction package. It's hard to imagine this is just a collection of parts bolted together as anything other than larger, higher loss and leaking EMC. I think before we continue, maybe we should do a quick poll with the audience. Katie, can you move forward and speak to the 2 poll questions?
Absolutely. Thank you so much, Joe. And I did just want to address, I know a couple of people in the audience have reached out about the connectivity issues we're having. So we are aware. We appreciate your patience with us and for sticking with us We are having a little bit of a technical difficulty with Alan's audio. So Joe doing great. Joe's here in case we can't hear Alan, so he will be kind of clarifying a few things as we go. Again, we appreciate your patience. Live webinars always sometimes have technical issues. So again, thanks for sticking with us, and great job, Alan and Joe. All right, so let's get to this polling question. But for our audience, for those of you who have tried it, how successful was it? So we've got a couple options here for you. Poor, never mention MFAs to me again. Each occasion has been a lesson learned, unlikely to do this again. Lessons were learned, would consider this if the right application was correct. And great, would not hesitate to do this again. So we'll go through those answers one more time. Please grab your mouse, click on your response, and we'll go over the results in just a minute. So again, the options listed here are poor, never mention MFAs to me again. Each occasion has been a lesson learned, unlikely to do this again. Lessons were learned, would consider this if the right application was correct. And the final one, great, and would not hesitate to do this again. So for our attendees, I'll give you about 30 seconds to fill out your answer, and then we will push ourselves out to the results. All right, I'll give everybody a couple more seconds to get some answers in for us. If you guys could participate, that would be greatly appreciated. Okay, we'll give you guys another 10 seconds or so, and then Joe and Alan, you guys can go over the results very quickly. Okay, so we are going to move into our results slide at this time. Okay, so Joe, here are our results if you guys wanted to touch on quickly, and then we can move to our next poll.
Well, Alan, looking at the response, the overwhelming response is actually mating up with what you and I consider the most important. Lessons were learned. Consider this application right, wrong, or correct. Would you like to do a brief overview on lessons learned as far as responses go? I think we're having technical difficulties again. Let me just move forward here.
Great.
Smith's Interconnect has found that the lessons learned, actually, we have built all these individual components. So obviously, if you build the individual components, you're able to integrate these components. What we have learned more than anything else is commercial viability and understanding from the customer. And from commercial viability, we mean things like, usually if you're looking at an MFA, you're looking at a more expensive subsystem. And as such, making sure that you are on the same commercial plane with your customer regarding quantities is a driving item. The next question, which ranked just about as high as lessons learned, would not hesitate to do it again. And I'm assuming that the audience here is at least subsystem, if not system houses, and that from a design point of view, from a real estate point of view within the subsystem or system, having a multifunction package that not only reduces footprint, but gains insertion loss and overall connectivity is a driving force. Katie, why don't we move to the second question?
Absolutely. Thank you so much, Joe. So our next polling question, before I get into that, we did lose Alan on our line. So as I mentioned, we are having some technical difficulties with his connection. So at this point, Joe, you are alone here. Hopefully you're okay with that. If we can get Alan back on the line, we will do our best to do that as we move through the rest of the webinar. So again, for our audience members, thank you so much for your patience. Again, live sometimes comes with technical difficulties, and we appreciate your patience with us. So Joe, I am going to read this polling question out, and then I'm going to pass it back to you. I will let you know if we can get Alan back onto the line. All right, so our next polling question. Yes. What is the number one advantage that an MFA brings, do you think? So our options here: lower mass and volume. Next one is better electrical specifications. Next one here, cost is lower compared to bolting components together. And our fourth option, it takes some of the strain from our internal resources. So I'll leave this question up here for about a minute or so, give everybody a chance to submit their answers. Go ahead and click on the answer that best suits you. I will read the question one more time. What is the number one advantage that an MFA brings, do you think? So again, our options listed: lower mass and volume, better electrical specifications, cost is lower compared to bolting components together, and the final one here, it takes some of the strain from our internal resources. Again, for our attendees, we appreciate you sticking with us through our technical issues, and if you could participate in our poll, we would love to hear from you. All right, I will leave this up for another 10 seconds or so. All right, Joe, I am going to move us into our results slide so we can see what everybody is thinking here. Thank you, everybody who participated. So, Joe, here are the results for our second polling question.
Well, very interesting. The number one overall response is cost is lower compared to bolting components together. And right behind that, which is obviously tied to it, is lower mass and volume. And they tie together. If you are combining components within one package, obviously the mass is lower, the volume is smaller, and usually there's at least a cost savings as it relates to procuring those individual components, because they are in a single housing, and they in most instances will be on a continuous board or circuit within. So this makes perfect sense, Katie, and the audience seems to be very well informed.
Okay, great. So we're going to move forward without Alan. So Joe, I'm going to kind of take over moving these slides. So let's get back into the webinar itself. So Joe,
okay.
How do these advantages compare, and what do you think is the most important?
Well, referencing this slide, regarding what is most important, let's go down the list. As far as electrical performance goes, obviously, if you're combining components together, you are not mating up individual components. Electrical performance as it relates to insertion loss, internal matching is an excellent point. It's probably one of the better features compared to buying the individual components. As far as mass and volume, and going back to the previous comments, mass and volume are going to be reduced, but compared to electrical performance and the third item, which is the robustness of the entire multifunction package, there's just from a reliability point, better performance with individual components put into a single package, again, from a connecting, bonding, terminating point of view. with our slide back a few slides ago showing 23 individual components put together, and the fact that it was bolted up with low noise amplifiers. Thermal efficiency is also a large driver in multifunction packages, and as such, the end user is focused on that a lot. Supplier management. It's easy for components. Supplier management with an MFA, as we said, you have to your end user has to be 100% in the loop as it relates to not only the specification but the schematics, the layout. It is much more management required. Dual sourcing, again, it's relatively hard with multifunction packages versus components. Usually the multifunction assembly supplier are using their own individual internal components. Those components are tied to that factory, those engineers, and as such, having somebody replicate it is a difficult cost. And again, development costs, usually these components are already in place. However, to put into a multifunction package, and the layout within that is a relatively high expense. So they usually have NRE with multifunction packages. Going down to intangible benefits, and it was mentioned earlier, EMC performance is much better within an MFA. You've got one sealed package. Integration costs are the lowest, and the reason being you have the individual components already, at least internally. The supplier of those components will have to integrate it, and it's just not a huge advantage for the customer in question. Spares and repairs goes along with dual sourcing. If you are supplying a multifunction package, obviously it's coming out of your factory. At the component level, it is more challenging because there's, of course, multiple competitors.
All right, Joe.
Moving on to the next slide, Katie.
Yeah, sure. So can you share or maybe illustrate some examples and comment on some of the lessons learned?
Yes. This is an X-band assembly that we did for an airborne radar package. Again, especially in an airborne environment, thermal management is a extreme issue, and electrical performance, given the limited size of an airborne package, is also a driving factor in airborne platforms. On top of that, in this specific issue, other than this using a standard standalone circulator, there was a filter requirement, and as such, the customer moved to this multifunction package as it both increased electrical performance and helped with thermal management in an airborne environment. Let me move on to the next slide, Katie. Now this one, unlike the previous slide where airborne platforms are probably one of the toughest technical environments, this one was a commercial X-band marine radar where cost was a driving point. And so what we had here, it may not be obvious to the eye, but the main point here is that the circuitry was put into a package, and the package was actually it was not a machine part; it was casted. And because we had the quantities necessary, being able to have this this housing casted versus machine drove down the costs and was a huge factor for our user. Moving on, this one it was a ground-based radar assembly. Again, unlike the airborne environment, cost was a driver, and as such, we were able to take the individual components and both increase performance and via both bolting these components together and brazing some parts, the cost factor was met, and the customer was happy. Moving on. I think we got the same slide here. Katie, I apologize.
Yeah, sure. Did you want me to advance?
No, I've got it here. It's okay.
Okay, perfect.
Last but not least, we mentioned the first airborne platform. Then, of course, it doesn't get any more expensive or more intense on the reliability side than in the space environment. And this is a Ka-band assembly taking care of 8 different channels. And by putting it into a multifunction assembly, especially from a reliability and space qualifying environment, this package was overwhelmingly accepted versus the satellite systems end user putting these things together by themselves. Last but not least, this S-band assembly was focused on electrical performance. Mass was a secondary consideration, but as you can see here, we not only have standard diplexing and combining, but we also have circulators and isolators involved. There was on the electrical performance, there was a strict phase requirement which drove this package and the ability to lower weight considerations.
All right. Thank you so much, Joe. So can you distill these lessons in an overarching advice?
Well, yes. Again, I think from the supplier and the end user viewpoint, obviously we have a lot of technical, highly qualified people out there. But again, on the supplier side, it's important that the supplier can do all the components, or obviously he can't do a multi-function package with those components in it. If he doesn't make all those components individually, it's tough to move forward with a complete package. And with that, the end user probably has a better trust factor in the fact that they know that the supplier can do this individually, and therefore the ability to combine it into a more complex package is a feasible, realistic goal. Again, technical transparency. It's really important that the understanding of what can be gained by putting multifunction assembly together and the electrical performance and mechanical performance incremental gains are understood at the end user level. And as far as commercial transparency, obviously it's got to be a win-win for both sides. With a multifunction assembly, you're not going to do this for a 10-piece quantity. This is something where there's going to be a long run of product and the ability to scale up over time. Going back to that previous section on marine radar, where we actually casted the final package, was a driving force in that commercial transparency. And again, expectations, both sides, both technically and commercially, everyone's got to be on the same page, so that the next round we can do it again.
All right, Joe, thank you so much. So I do want to ask, why are so many of these MFAs in waveguide?
Well, waveguide lends itself to a variety of examples that can't be performed in other environments, especially when it relates to EMC performance, height performance. That being said, and the ability to transfer from one area to another, a waveguide to coax transition, and package constraints. Waveguide has been the primary focus with most of our end user base. That going forward, there's going to be situations where we're looking at, this is a UHF space application. This will be casted. It will have ferrite filters. It will have ferrite devices. It will have RF filters. The mechanical design is one of to conserve a huge amount of space, and of course it's going to be in a space environment, so multi-paction and corona testing is a huge item of that. Hold on just a second here. Now I've had technical difficulties.
That's all right, Joe. I can move us to the next slide if you'd like.
Yeah, would you do that, please?
Sure. So, okay. So, Joe,
let's see. Hold on.
I guess what has been our roadmap moving forward?
I'm sorry. There we go. I've got it. Going forward on that roadmap, we're looking at this is a KU band radar assembly. Again, this is will be an airborne platform. What you see here is a combination of circulators, filters, couplers, and this sort of configuration we're being within the radar community in particular, where we may or may not have to bolt up to a manifold, is becoming critical to our system suppliers. And here we have a C-band coaxial assembly, and you have both an isolator, a coupler, a low-pass filter section, and a band-pass filter. And again, this is both for not only performance, obviously insertion loss, and mismatches are reduced because it's one package, but also because of, again, everybody wants a product to be smaller and fit in a more confined package and to address thermal concerns. Here's another one, a KU band transmit assembly, very similar to what you just saw. This is, again, you have an isolator up front. You have a coupler between the isolator and the bandpass filter section. And this, again, is because of not only thermal, but performance considerations versus buying the individual components. Last but not least, moving from the waveguide and a coaxial world and moving into microwave integrated circuits, we're now able to take a ferrite device and we're actually able to print our own circuit and also put a more than one component on it. So what you're looking at there is actually an isolator, and because we can now put our own circuit on that piece of ferrite, we no longer have to procure the individual termination. It's part of the circuit. And what you have here is not only just a standalone microwave integrated circuit isolator, but it's combined with a Wilkinson power divider. Again, so let me summarize what today is. And basically we have two summary points, recommendations from the buyer's side and what the supplier should always bear in mind, the people who are making that multifunction assembly. On the buyer's point of view, engaging as soon as possible is critical. And I realize that, every subsystem and system house has got a timeline. But the earlier you engage at the multifunction level, if there's an interest in it, the more time there is to review the technical nuances within. Again, what has been stressed here on several occasions has been if you're going to procure a multifunction assembly, the supplier should be able to make every one of those individual components within the assembly. Because if they can't do the individual components, there's risks to the buyer that they will not be able to totally integrate something they haven't done before. Again, this is on the technical side, sharing expectations. What's the buyer have for a package? What's the schematic? What's the general requirements? Environmental, EMC, all of the above. The ability to put that into the supplier's hands is extremely important as to overall performance of the multifunction assembly. And again, be realistic on the commercial side. There's going to be development phases. Quantities are even more critical on a multifunction assembly than they are on an individual component. Driving that cost down obviously happens over a learning curve, and quantities drive that. And finally, again, touching on the second point on the supplier side, and we take it very seriously. Our customer is putting all their eggs in our basket, and therefore we're going to, reach forward and deliver as much truth and cooperation as possible. Okay, then. I think, how are we doing for time here, Katie?
Sure. So great job, Joe. We have about 15 minutes left. We have a couple questions in our queue. So at this time, I think we're going to move into our Q&A section. So I just wanted to say one more time, thank you all for sticking with us. We do realize we had some technical issues here, but Joe did an amazing job filling in for Alan. And we are going to take a couple questions right now. So for all of our attendees, if you do have any questions, you can enter them into that Q&A window and click submit. We only have a few minutes left, so we probably won't get to most of the questions today, but we can reach out to you following the webinar today. So just a few notes before we move into the Q&A as well for our attendees. We do have some items listed along the bottom of our webinar console in our widget. We have a survey down there. We have some resources. So feel free to grab those resources on your way out before we end today. Those are listed right in the window below our Q&A window. So you'll see all of those listed. You can download those. So take a moment to do that kind of while we're going through our Q&A. All right, Joe, so if you're ready, I have the first question here. This person is
Go right ahead, Katie.
All right, let's do it. This person is asking, how long does MFA take to get prototyped?
That's a good question, Katie. Usually with an MFA, as we're going to combine individual components, and there's usually a unique specification from the buyer. I would say that there's going to be let's call it an NRE/development exchange, and depending on the system level, or at least the subsystem level requirement, I would say that there's going to be a 3 to 4 month exchange back and forth on specs and or overall both electrical, mechanical, thermal, environmental concerns. That may get pushed down to 90 days, but I would say that the spec would probably be in place within 90 to 120 days. And depending on the lead time of the individual components within that multifunction assembly, I'd say that you're going to have another 3 to 4 months. So from initial concept and discussion to first prototypes, cutting metal and delivering, I'd say it's somewhere between 5 and 6 months. You may be able to compress it down to 4 to 5, but that's an aggressive schedule.
All right. Thank you, Joe, so much for that answer. All right. So we've got time for 1 or 2 more questions. This person is asking, I saw UHF and KU band. Is there an upper limit?
No, there's not an upper limit. Well, there's an upper limit as far as test equipment goes. We have at our facilities VNAs that go up to 110 gigahertz. At this point in time, if I had to give an overall statement, we have not seen very much MFA activity above KA band at this point in time. We talk about QEVW band. We see little interest there. It's at only the component level. Going down in frequency, there's a lot of activity within the traditional S through X radar bands, and with the example of UHF, yes, on the ground-based platforms, UHF through L band is becoming more popular, not only on new systems, but retrofitting older systems.
All right. Thank you so much, Joe. All right. So we're going to do 1 more question today, and then we are going to wrap the webinar up. So before I ask the last question, just a reminder to all the attendees, if you want to download some of those resources, now would be the time. They are listed in the resource widget just below that Q&A window. So go ahead and grab those before we end things today. And you will be receiving a link following this webinar in an email from us. So go ahead and keep your eyes out for that. All right, so last question here, Joe. How much is an average NRE cost?
It all boils down to we have individual components. Most of our individual components, when a customer comes in, there may be a scaling or a redesign of a component to meet a new requirement. If you put that across the entire spectrum for a handful of components within a multifunction assembly, I'd say you're in the plus or minus $10,000 area. And if you're talking about the example we had of maybe the 20 component package or 23 component package, you're probably speaking in terms of more in the $50,000 plus or minus package overall, if I had to give a rough order of magnitude.
All right. Thank you so much, Joe. So that brings us to the end of this webinar today. So as I mentioned a few times, we appreciate you sticking with us, even with the technical difficulties, and a huge shout out to Joe for taking over the webinar today. Thank you so much for being here, Joe. We really appreciate it.
Of course, Katie, and we appreciate you sponsoring this event.
All right, thank you so much. And a huge thank you to Alan as well for creating a lot of this content, even though we lost him. So thank you both so much. And a huge thank you to our audience members for being part of this webinar event. Again, thank you for sticking with us. As I mentioned, we've got resources listed there. Go ahead and grab those before you leave today. You will be receiving an email from us with a link to the on-demand version of this. And lastly, a survey is going to pop up on your screen. So for on-demand viewers, you'll find that located along the bottom of your attendee console in that survey widget. So again, thank you everybody for sticking with us and for taking time to attend this webinar event. Take care, and we will speak with everybody soon.